We are now looking at question 2 of the consultation worksheet on vectors. Part A, they are asking us to express the vector PQ in terms of P and R. And of course, to find the vector of PQ, we need to know that the PQ consists of OP and OQ, which OQ is not known yet. Therefore, we need to actually look for something given by the question that could produce OQ. So we'll make use of the relation RQ equals to 3 times of OP. And when we take a look at the left-hand side of the equation, we're able to resolve the vector RQ to become OQ minus OR. And the right-hand side of the equation remained as 3 times of OP. So since we want to find the vector of OQ, we shall then make it the subject. Therefore, it equals to 3 times of OP plus OR, and we will substitute what the question gives us. OP is equals to 2P and OR equals to 3R, and from here we know that OQ is equals to 6P plus 3R. With that, we are able now to find the vector of PQ by expressing PQ as OQ minus OP. Substitute the OQ that you have just found, 6P plus 3R, minus OP, which is 2P given by the question. And that gives us the result of PQ vector equals to 4P plus 3R. And that ends part A. For part B, we were given the vector of QS, and we were first asked to find the vector RS. Okay, we can study the diagram right now, and we know that RS is this vector indicated, and there are many ways to build the vector RS. Perhaps based on what we have solved so far, the best route to go by is to go from R to Q, then Q to S. So we will say RS vector equals to RQ vector plus QS vector. Okay, to observe that vector RQ, it has been found, which is 3 times of OP. Then vector QS is the one that's given by the question, 3 over 2R minus 4P. 3 times 2P equals to 6P. Negative 4P bring to the front. Then followed by 3 over 2R. Then we perform a simplification. Then the vector RS equals to 2P plus 3 over 2R. And that ends the part 1 of part B. Part 2 requires us to show that the vectors RS and PQ are parallel. Now again, we do know that if two vectors are parallel to each other, we should be able to express one to be the scalar multiple of the other. And of course, this scalar multiple is to be found. So we know that RS is equals to 2P plus 3 over 2R, and PQ from the previous part we have found that it should be 4P plus 3R, and it's clear to us that RS is only half of PQ. So since we are able to determine the scalar multiple K, which is half in this case, so therefore we can easily show that RS vector is parallel to PQ vector. And with that, we end part 2 of part B. Part C of the questions requires us to find the numerical value of the ratio of the areas of triangle. So firstly, let's take a look at part 1. Part 1 asks us to find the area of triangle QSR over the area of triangle QPR, sorry. So let's identify where these two triangles are. And from here, we will have to go and find out whether or not these two triangles, they share common dimension, or is there any information that we have found from the previous part that tells us the relationship about some sides of this triangle. Now from your part B, part 2, you have shown that RS is parallel to PQ, and in particular RS is half of PQ. That means to say that if RS is worth 1 unit in length, then PQ is that 2 units. So therefore we can treat RS and the PQ to be the respective base. And notice that for these two triangles, we identify that they have what we call the common height, as indicated by H in the diagram. So therefore, to answer to this question, area of triangle QSR over the area of triangle QPR we will then adopt a very simple formula of half times base times height. So for area of QSR, you notice that RS is our base and is of 1 unit in length. So we will say that the area is half times the base, which is 1 unit, times the height, in this case the H. As for the area of QPR, you notice that the PQ is its base and it is worth 2 units. And this triangle also have the same height, H. So perform cancellation, and you notice that the ratio of the area of the triangle is equals to half. And that ends part 1 of part C. Now what does this half tell us? Of course, over here we can say that the triangle of QSR is worth 1 square units, and therefore the area of QPR is worth 2 square units. So in answering for part 2 of part C, which is the area of triangle QPR over the area of quadrilateral PQSR. Now, in our earlier discussion, we see for ourselves that the area of QPR is worth 2 square units, and the area of PQSR, it is worth 3 square units. Therefore, the area of triangle QPR over area of PQSR equals to 2/3.